choose the statement that is true. And this question deals with core electrons versus valence electrons. Before I answer this question, let me tell you what core and valence electrons are. We cover this in the lecture outline, but it's worth saying again. So, and let's choose an example. I'm going to choose, let's choose phosphorus. So the phosphorus atom, if we were to do its electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p3. Now, electrons with the highest value of n are the valence electrons. And all other electrons are considered core electrons. So all other electrons. And in fact, one way that we hide the core electrons, or most of the core electrons, is we use a noble gas core. So we could also write this as neon 3s2, 3p3. And with this noble gas core, and it's not always perfect, but at least with this one, it is only the valence electrons that are outside of the noble gas core. Phosphorus has 5 valence electrons. Another thing we talk about is that if you look at the group number, so phosphorus is in group 15, also sometimes called group 5A. The ones digit, either 5 or 5, same thing, is how many valence electrons there are for every element in this group. Okay, and why do we care about valence electrons? The valence electrons participate in bonding. So I'll just note, why do we care? Because valence electrons participate in bonding. And bonding, and it's hard to imagine, we haven't really talked about bonding yet, but we will. But that's why we're building up to it. Okay, so jump in anytime if you have any questions. Otherwise, I might actually try and answer this question now. It says, choose the statement that is true. Core electrons effectively shield outer electrons from nuclear charge. So now let's talk about, so that actually is the true statement. And if we think about our atom now and our picture of the atom, then we've got our nucleus at the center. We've got n equals 1, n equals 2, n equals 3. And the point that we're trying to make with this is that the n equals 3 electrons are outside, and our core electrons are between the nucleus and our valence electrons. between nucleus and valence electrons. And so our valence electrons, like this nucleus, if it's for phosphorus, is plus 15 because it's got 15 protons. But then there are 10 electrons in between. And that's what we mean by shielding. So it's like the electrons block all of that positive charge coming from the nucleus and reduce it. So that first statement is true. Effectively, we're done with this problem, but let's go ahead and read through the other ones. So valence electrons are the most difficult of all electrons to remove. Well, that's false because the outer electrons are the easiest to remove. Well, core electrons are the easiest of all electrons to remove. That is also false for the same reason we just gave. And outer electrons efficiently shield one another from nuclear charge. Well, the outer electrons are in their orbitals and not inside, so this one's false too. So, in fact, there's two things we learn about this. First off, that the first statement is true. Second off, what shielding means. And third off, just what valence and core electrons are. I think I said there were two things, but I guess there were three.